Good morning. Good morning, everybody. Are you still alive? Okay, we're going to do a quick test. If you're alive, raise your hand. There was a few people who didn't raise their hand. I'm a little bit worried here. Okay. Welcome to Leveraging the Power of the Cloud session. What we wanted to do with this session is do something fun and show you some cool demos we've been, playing around with. And technology is something that moves along and changes and evolves. Like this technology, it was great at some stage, but then it evolved into something else. And sometimes you have to leave it behind and move along with the new things. And that's also what we've done with Business Central, with NAV. We're moving along, following where technology is taking us. And the cloud is certainly one of the big things that happened for our industry in the last 10 years or so. So getting to the cloud also, and getting to this new technology also opens up a whole new world of possibilities. And what we wanted to do with this session is give you a sample, a tour of some of these things. Obviously, there's a lot more things you can do, but hopefully you'll find it inspiring and go out and check all the goodies there is on Azure and in the cloud. And by the way, most of the thing we're going to show here is not only for the cloud, but also can be used if you have an on-prem system. Before we jump into it, I'd like to have a few words around the code we're going to show you here. Everything will be or is available on GitHub, so you can download it and use it as you want. Integrate it in your solution. There's no IP problem. It's all free to use. But it is prototype quality. It's code we have been writing most of the time outside office hours, and it's not production quality. So if you want to use it in a professional environment, you'll need to bring this code to production quality. And with that, let's jump right into it. And Esben, over to you.
Thank you.
Here's a clicker.
Clicker, thank you. First of all, before we are going to talk a lot about Azure services and how you can integrate with them. And one of the key concepts with many of them is that they allow you to access them using REST and HTTP. And a very common authorization mechanism is actually shared key access. So I thought I would start just by explaining how it works, because it's actually fairly simple and a smart and clever way of doing it when you have sort of a service-to-service type of authorization. So the key principles is basically that you have a service that exposes a REST API and a client. And in most of these samples, the client is actually Business Central, and the service is a service in Azure. The idea around it is that these two services are sharing a key, hence the name, shared key. And they use the shared key to sign some information from the request that can be verified on the server side. So it uses the key to sign in the case of a REST, which is actually the URI is an important part of it. Often, or always, I think the URI is included, and then it adds in at least a timestamp, a time to live. How long is this request valid? So even if you intercept the request, you can only actually replay the same request. So the idea is to use public-private key to sign the request on with a hash on the client side, send it off to the server, and the server, as part of the request, the name of the key is actually in the request, so it knows where to look it up and say, okay, this is the listener key or the sender key if you have multiple different key types. And it actually then can verify that the request is signed with a valid key. One of the services we're talking about today is the Azure Service Bus. It does it in one way. Azure BLOB Storage has a slightly different way of doing it, but the principle is actually the same. So for the Azure Service Bus, it signs the URI. It signs and includes the resource, and all of that goes into a header, which is the authorization header that says shared access signature, contains the signed parameters, and then the the signed value at the end. And then that is then used by the server to verify it. Even though it sounds a bit, actually sounds very simple, it's a bit tricky to do it in AL. So, I mean, some of these samples that we have published includes this functionality, so it's easy to get started with it. So let's jump into the first one, which is about files and storage. A common problem that many of you are probably facing is that if you have done a lot of on-prem integrations, you have been using the file object, which we took away in the cloud. And the file type doesn't really mean a lot in the cloud. I mean, after all, it relates to C drives and files on a network share, but in the cloud it's a bit different. A file is basically just a stream of bytes, which we have organized in some shape or form. And when we normally think about it, we tend to think about it in the context of the classic DOS directory structure, which is just a representation on top of storage. Most of you are probably all using OneDrive or Dropbox or one of the other providers to have a backup of your files in the cloud. And even though it looks like they just have a C drive in the cloud with your data, it's not actually the case because it's not that efficient in a cloud service to do that. So when we start moving our IP to the cloud, we should start thinking about what are the data that we are storing and how would we actually like them to be organized. Maybe a directory is not the right way to view them in the cloud. Maybe they should be shared in the context of other objects, which is not necessarily directory organized. So let's jump into the demo. And I will switch to this one. So this is Business Central running in the cloud in our data centers, so it's not connected to anything local here, apart from my PC. And let's jump into this. I will see if I can make it bigger. So this is actually Azure BLOB Storage underneath. It's not blobs in SQL Azure. It's not blobs or files shared on my C drive. It's actually a peek into my Azure storage account. And what I've built here on top is a couple of, I have a small problem with my mouse here. It's basically a directory browsing similar experience, but it's actually just built on top of BLOB Storage. So I can pick files, I can take this one and can download it. And it will actually download from Azure BLOB Storage through Business Central to, in this case, my C drive. And it's a picture of a car. So let's go back here. So how's this done? Basically, it's using the REST API of Azure BLOB Storage with shared key access. In the samples that we have published, I have added a list of supported operations here, which is a subset of what you can actually do with BLOB Storage, but it's a good way to get started because most of the underlying mechanics are actually included. And actually, the last one, delete blobs, is actually a contribution from Bart van Beek down here. Front row, I have a t-shirt for you after. And it's the first contribution to our GitHub repo with some code that you have added, in this case Bart. And I hope if any of you start using this and find, I don't know, bugs, improvements, feel free to contribute. And at some point, It may even find the way into the base of the product and be fully productized, but for now it's a sample, but feel free to help us improve it. The samples here, to make it easy to get started with, are all set up using the normal service connection setup. And there's for reference in this, I'm not going to go in details here. Basically, it has a setup dialog. You read the slides, and you can see where you should put the various parameters to get started. It's very easy to try the samples out yourself. This is how you upload a file. Basically, use the built-in upload to stream. And then the Azure BLOB Storage code unit wraps all the functionality. So basically, put blob into my container. This is the name. Here's the in-stream. And it calls a get content type from file name, which says if it's a PDF, it gets it the right MIME file type and uploads it with that. So one of the other things that you are missing, and we know it because we have heard it many times, the use of .NET interop and external functionality. For service reliability and security reasons, we cannot allow you to bring any arbitrary component into the cloud. So one of the options for this is basically to externalize some of that functionality. And a very, very good way of doing that is to use Azure functions. They are designed for that. It's serverless computing. You write a simple function, and it's fairly powerful. So, by the way, this picture I accidentally took when Directions Asia was in Kuala Lumpur this spring, and I was standing on a rooftop and took a picture, and lightning struck. And since we normally use lightning as an icon for functions, I chose to put it in. I think it's a great picture, in my personal opinion. So let's do a demo of what we can do here. As a demo of what you can do in an Azure function, I have chosen to put in the functionality to make a picture monochrome. Just before I downloaded from Azure BLOB Storage, the picture of a car, it had a color. But I can actually, if we navigate to the same file again, come on, here, I've actually added an option here to download Monochrome. And what it actually does is that it pulls the picture of Azure BLOB Storage, sends it off into an Azure function, which do the heavy lifting of the Monochrome conversion. It's probably not something you would write in AL. Bring it back, and then download it. So let's try that. And while this short period of time, it actually read it from Azure BLOB Storage, sent it off to a service, and I actually think they are different data centers, and made a Monochrome copy and downloaded it into my PC here. So it's a very efficient way, and also fairly easy to wrap the code. If we go back here. So this is the Azure function I used. As you can see, the actual part of it is 8-10 lines. The rest is just some boilerplate code. And I'm using an external library. So that I can do, upload that. Sorry. And when I call it from AL, it looks like this. There's a bit of preparing arguments. I'm converting it to base 64 before I send it off. And then there's the call, and the return and the conversion back again. So these were two examples of some of the challenges that you will be facing when you are trying to convert integrations to work with the cloud. Even though we are trying to move a lot into the cloud, we all know that there's a lot of integrations and systems which are still firmly rooted in the ground. I mean, some examples here. Barcode scanners, it has to be in the store. Payment terminals, a scale, for instance, heavy machinery on a factory floor. All of that is not going to end up in the cloud. Maybe at some point in time, some of these will be integrated into the cloud with, for instance, IoT, which Gert is going to talk about. But right now, the reality, a lot of this is not in the cloud. So what can we do about that? Is there a way that we can bridge between the cloud and on-premise? I mean, essentially, this is the problem. We have a cloud service and we have something on-premise. And that something is always behind a firewall. If it's not, probably don't want to talk to it anyway. And early on, we had this nice little insider we could rely on. I mean, we could send something to the RTC client with the run-on client, and you could actually execute the .NET locally. But with the removal of that, we are left with a web browser, which for many good reasons are running in the sandbox and cannot do anything locally. So that's not really helping us a lot. So let's see if we can find a good solution for it. And let me first do a demonstration here and talk about what I did after that. So I have put here a file browser. And this is actually my local C drive, which I'm navigating through from the cloud. And can go into folders. So, and you can see it's actually fairly fast, but I'm actually accessing local resources. So how am I doing that? So again, this is the problem. So how do we get around this? We introduce Service Bus Relay, which is an Azure service that allows you to create connections between separate networks. Azure Service Bus is an umbrella for a number of services. They share a lot of common technology, but the Service Bus Relay is basically a way of having one service that is a listener and another one that's a sender, and they will be able to communicate using functionality which is very close to HTTP request. So, look like this. What we have done is that we have built a framework which we have put on GitHub, and that framework takes away a lot of the complexity around doing this kind of communication. It allows you to write a plugin in C# or actually any .NET language, which will be picked up by a local agent that you run on-premise. And that local agent then exposes functionality that you can connect to from the cloud in a secure way. And the idea is that you then write a matching extension. In this case, I wrote one, which I wrote a plugin, which is the one that actually allows me to ask locally, give me the files in a directory, and an extension that actually wraps that functionality and adds a sample code with a browser and some pages on top. So the flow is here. I have a plugin, and the plugin starts to create a listener using, again, a key from Azure saying, I want to listen to this endpoint. And then an extension, in this case my browser extension, initiates the communication through Business Central, some framework code there, which is actually also an extension. All of this you can download and play with yourself from GitHub. And then it sends the request into Azure Service Bus Relay. And the Azure Service Bus Relay says, okay, I have a listener for this, and forwards the request down into the local agent, down there, on-premise. And that one is actually responsible for forwarding into the correct extension, or the correct plugin. The plugin picks it up. Does it work? In this case, it could be give me a file request, sends the information back all the way up to Service Bus Relay, back to Business Central, and back into as a reply to the original call. So the way it's built up is this duality. We have plugins, we have extensions. You can see on the left side, this is a sample of a small calculator plugin. Probably not that interesting, but it's a nice sample here. Basically exposes an add and a subtract function. And the right side is the corresponding extension that wraps those two calls. So it's easy to access. Basically, you can, the consumption of this is basically add a reference to a code unit, and you can do calculator.add, and all the magic happens behind. There's these matching things. There's the agent plugin in the C# code, which basically says this is the relative endpoint that you are connected to, and on the right side is basically a part of the request. It says that it's a get call. It uses the get method in the code unit helper. And parameters are actually put on the URL. And the framework automatically unpacks that, converts it, and sends it into the C# method that can return a value. All this is built into framework, so it's very easy to add new plugins. And again, the configuration made easy. You can read that yourself. And again, there's a local part of it, of course. That's a local agent. Is either, in this case, I run it as a command line. There's also a sample where it's set up as a service you can try out. And again, number of parameters that has to go to the command line for it to work. But that's it. So, and to do a final demo, I actually tried to get this guy here, and I wanted it to drive around on Mars. I think that's the last known location, and do a giant BC logo. Unfortunately, it's very slow, and no one really knows where it is right now. So I had to do something else. And I wanted to have some old technology, so I ran around in my basement and found this little guy. Actually, it was not built when I found it. I asked my son to do it for me, say I need this, so go build. This is a prime example of some of the old technology that you will phase out there. This is from 2009. It's an old API. It's actually Bluetooth connected to my Surface here. I had to dig deep to find some old documentation of how it worked. But it actually, I have actually integrated this using the same mechanism. I use the service bus relay and the local agent to connect to it. So let me see if we can bring it alive. First of all, I want to show you the local agent. It's here. It's basically just a command line, and you can see it currently logs whatever I do on it. There's the, from before, the get drives, get directory items. That was the call I needed to get the directory before. So if I do this, next brick control, it should query it, and you can see that got a couple of new entries here. Get firmware version, protocol version, battery level. You can see here some data from it. And I added some additional calls to it here. First of all, I can ask my helper here young assistant, Bardur. He will help me, and I have prepared some questions for it. So can I ask it to tell us about Business Central?
I love Business Central.
Can try again. Oops. It's complaining now.
Yeah, that's cool.
So, and as a final experiment, I will try to make it dance. I will not do it up here because it will definitely commit suicide if I try it from this one. So let's see if it works better there. So, while this is fun, and it was definitely fun doing it, it's a very good example of what you can actually do with this piece of code. Oh, yeah. It's not completely trained yet. Thank you. And I will hand it over to Gert.
Yeah. So what Esben showed you is how you connect some technology and some hardware to the cloud and interact with it through the cloud, but it's mostly meant at being used with old technology, that is one which doesn't have basically an internet connection. So things like the robot or scales and barcode scanners, some of these old hardware, they don't connect to the internet. So you don't have you have to do something. You need to run an agent like Esben showed you on some PC to connect with it locally, and you can use the Azure relay for that. Now, I'm sure you have heard of Internet of Things. It's kind of a buzzword. You hear it all the time. Internet of Things is basically allow you to do the same thing, you connect hardware to the cloud, but it's for hardware which does have the ability to connect. And it's for things that are a little more modern. Typically, sensors, thermostats, this kind of thing. And that's what Gert is going to talk about.
Thank you. Does it work? Yeah. So to show you some stuff about Internet of Things, I built a connected cookie jar, which we had running in the office for a little bit. So you can see it here. In the base, in the tin is actually this stuff that you can see up here, which is rather small. It's a scale, so it measures the weight of the cookies, and when the cookie jar is nearly empty, it connects to the cloud. It connects to Business Central and creates a purchase order, which is sent out for approval. And when it's approved, you can get more cookies. So as you can see, we did run this in the office, and people enjoyed their cookies. So for people who like Arduino, it's not an Arduino device, but it's based on Arduino, and you can code it with Arduino. So this is the wiring diagram. It's a small device. It connects to the Wi-Fi, and on the bottom right, that's the scale part, and on the bottom left, you can see I have temperature and humidity as well, just to get some more data. So I'll show you. So to connect it to the cloud, I used IoT Central. So Azure IoT Central is a service that makes it really, really easy to connect devices to the cloud. They handle all of the infrastructure bits in Azure for you, so you really don't have to know what's going on behind the scenes. So here's a little diagram before I show you. So on the bottom left, you see the IoT device, which is connected to Wi-Fi. That one sends telemetry to IoT Central. IoT Central connects to IoT Hub, IoT device registration, all of those infrastructure services, so we don't have to worry about them. And you can set up rules in IoT Central. When the rule fires, you can do many things, but I had it trigger a logic app. The logic app does some authentication magic. It connects to Key Vault to get some secrets, and then it triggers a custom API in Business Central, which will run a workflow to create a purchase order and send it for approval. So now, just before I show you how all that works, if I can get my trackpad to work. So the people at IoT Central, they published a repo on GitHub where they have sample code for all sorts of devices. So the one I'm using is the third one on the list, ESP8266. But if you have a different kind of device, you can still connect it, using this sample code, and you really don't have to worry too much about the secrets behind it. You can just copy paste it and run it. It's very easy. So to show you IoT Central, if I can get the mouse to work. that doesn't work either. Okay. So, IoT Central, when you create an application, it will look like this. And what you have to do is you have to create a device template. So in my case, I created a template for cookie jars, and I configured it to have some telemetry, so humidity, temperature, and weight. And you can see the data coming in here. So this is a graph of the last 10 minutes, so not much going on. And if you're wondering, I think this is temperature. I don't know if it shows. No, it's not showing how much. So other things you can set up settings. So this is settings for the device. So in my case, I wanted to be able to control how frequently telemetry is emitted. So in this case, every 10 seconds, it will send data from the device to IoT Central. I also defined some properties. This is usually just properties about the device, like serial number, location, those kind of things. In my case, it's whether or not an order is pending, so that I don't create orders over and over and over again. You can also set up commands that you can send up back to the device. So in my case, resetting the scale to 0. That's very useful because when it's all hidden away, you can't access the device. So it's nice to be able to do it from the cloud. And of course, some rules. So I have one simple rule when I'm low on cookies. So that's when I'm not waiting for a refill and the weight is less than 125 grams, I will kick off this rule. So as actions, I know it's a little, yeah. So you can set up email, so you can just get an email. You can call a URL, call a webhook. You can call an Azure function. You can call logic apps, which is what I used, or you can use Flow, or you can connect it to Azure Monitor action groups. You can do all of those things. So once you've set up your template, you can set up an actual device. So in my case, I have a cookie jar. It's cookie jar 1. And what you need to connect this is all you need to do is go to this little page, and it will give you all the information you need that you can plug into the sample code. And so the scope ID is basically the application you want to connect to. So in my case, it's my cookie jar app. The device ID, so that we know which device it is, and a key. You copy paste those into the Arduino code, and it will start emitting telemetry. So the samples are really super easy. So from here, I can also control the settings, and I think it's, nope. If I do this correctly. So right now I have it connected to my PC as well, so I can see what's going on the device. Normally it wouldn't have this connection, but we can monitor it through the serial bus. And so if I wanted to have my data more frequently, so if I set this to update every 2 seconds, you should see that the device receives this event and now it starts emitting telemetry every 2 seconds. So it's two-way connection, which is very nice. So, this screen looks very much like the template. So there's really not that much magic. You can send commands. You can reset the scale. So when my rule triggers, I kick off a logic app. So I can show you the logic app that I have here. It's not very complicated. So when a rule is fired, this is the IoT Central connector. It's very easy to configure. You don't need to know anything about authentication. It just works. So when I'm low on cookies, I get the device by device ID so that I can read its information. And if pending refill is true, I do absolutely nothing. But when it's false, what I do is I call another logic app to get an access token for Business Central. So that's where the authentication magic happens. And then with that token, I can call my Business Central API, which you can see here. And I pass along all the information that I want. And when that returns successfully, which means a purchase order was sent for approval, I update the cookie jar and set pending refill to yes. So I can show you the other logic app. So this is the one that does the authentication magic, which is reusable. So it's one logic app, but I can use it for any connection to Business Central, not just the cookie jar. So the first logic app will send an HTTP request, and this logic app will receive that request. When it does, it connects to Azure Key Vault, where it retrieves a refresh token that I set up manually before. It parses all that data. It also gets the client secret from Azure Key Vault. And with that data, it will do an HTTP post request to get a new access token and a new refresh token. Then I connect back to Azure Key Vault to store the new refresh token, so it's ready for next time. And the reply back is just the access token and the token type, so that my other logic app can connect. So obviously we want to be secure at all times. So exposing these secrets is not something you want to do. So you can see on some of these, there's a little lock. And what this does is it hides the input or output of the action so that you can't see what happened. So I can show you that if on one of these runs. So if we try and see what the refresh token in Azure Key Vault was like, it's hidden. So you can give certain people in your organization access to editing the logic app. Obviously they can see the outputs because they can change the logic app, but you can give access to other people who can see the history, but they can't edit, and so they will never see your secrets. So that's quite nice. So when the logic app calls the custom API, we get into Business Central, and in Business Central I created some extensions which add some workflow capability. So in this case I have two workflows. The first one is this one, which is when a measurement is received, then create a purchase order based on some setup that I created, so I know which vendor and which cookies to buy. And it will send that order for approval. And when it's sent for approval, the second one, that's just standard purchase approval workflow that ships with the system. It's in Danish because I have a Danish tenant. So that's kind of how the whole thing works. We can do some more things. So over here I can see I have a device. So this happens to be my cookie jar. We can, using HTTP requests, we can connect to the IoT Hub backend and ask details about the device. So in this case I parsed out just the settings. And now I should go back here. So from Business Central, we can do the same thing. So if every 2 seconds is a bit too much, we can change it back to 5 seconds. And you should see the device gets the event, and now it starts emitting every 5 seconds. So I think that was that part of it. So that's not the right slide. Is it? Yes, it is. So this is, again, the diagram that I just showed you. So the device connects to IoT Central, which kicks off some logic apps and then controls a custom API in Business Central. So IoT Central has some other features that are very nice. So one is continuous export. So I can show you the diagram for that one. The device connecting to IoT Central, that's the same, but now from IoT Central, it will export data to Service Bus, and I'll have a logic app that receives messages from the Service Bus and then does the same connection to Business Central. So what would you use that for? So if I go into IoT Central, and I wanted to create some new devices. So I can show you how easy it is to create a new template. In this case, I'll choose custom, so I get a blank template, but you can pick one of the others that come predefined. So let's give that a name. So once we have our template, we can add some telemetry. Let's add weight as some telemetry. You just fill in some of these details. Weight would be in grams. Let's go 0 and 1 kilo. And no decimal places. So I can save that. So this is just a template, so nothing's really happening yet. In settings, maybe we want to display a message on a device if it had a screen. And we can do that. And we can say hello world. And save that. So now I have a new device template. When I now go to devices, I can see my new template, and automatically it will set up a simulated device for you. So even if you have no hardware, you can still try this out. This simulated device is, right now it's being set up, so, oh, it's already done. So we have some data. IoT Central will create random data for you. Not entirely random, but it's demo data, so that you can try out all your integrations. You can, make sure everything works. So if I now go to Business Central and refresh this page, I should. Now I already see that I have 2 devices, and there's my NAV TechDays simulated device. So what happened is that in IoT Central, I set up a data export, and you can pick where you want to export this to. So you can export to BLOB Storage, Event Hubs, or Service Bus. I chose Service Bus, and I chose to export all my device data. So here you can see you can export all the measurements, device templates, but I just wanted the devices so that I can push my setup to Business Central and I don't have to set up anything manually. This data gets pushed to the service bus, and it gets picked up by a logic app. That's not what I wanted. This one. Yeah. So it's pretty simple logic app. It works kind of like before. When a message is received in my queue, I get an access token. That's the same logic app from before to get an access token. And once I have the token, I call a custom API for my devices, and I send over the data. And I don't have to worry anymore about setting up my devices in Business Central. So that was what I just showed, the same diagram, IoT Central to Service Bus, back to Logic Apps. So this is a fun scenario, but IoT and ERP, there's a lot of scenarios you can use it for. Some common ones are automating time registration using smart devices. You can have fingerprint scanners, facial recognition to know who was working at what time, at which station. You can track your shipments in real time. Like if you order a pizza, you want to know when the guy is going to come. That's all IoT devices. Inventory management, real-time inventory, no more, counting all your stock every week or every month. You can track consumption of production processes, how much scrap you produce. You can use it in a warehouse to automate pick lists using RFID tags. And a big one as well is in service management. So modern equipment is typically full of sensors that emit data. So if you detect anomalies, you can detect problems before they occur and send out service people before the machine breaks down and your customer can't work anymore. So with that,
thank you, Gert.
Over to you.
Thank you, Gert. So what Gert showed you, and Esben, is how you can leverage some of the services in Azure. And it was a lot about connectivity and interacting with on-prem and this kind of thing. And now we're going to move into a different type of services, which are the cool one based on machine learning and artificial intelligence. Bardur?
Yeah, thank you. Can you hear me?
No?
Yes?
Yes, you can. Good. So yes, we'll take a look at cognitive services and in particular vision, and even vision is a big thing. So cognitive services is actually a subpart of the bigger Azure AI and machine learning family, and as you can see, that has a lot of different things in there. And even cognitive services is a lot. So you can see it as vision and language and so forth, Bing integration if you want to do search within your app. So we'll focus specifically on computer vision and more specifically on recognizing handwritten and printed text in a picture. So by the way, analyze images is one thing. We can do face recognition and so on. Moderate content will be to protect your kids from naughty pictures. And the OCR of printed text, that's an oldie, but it's also up there. So, but we'll take a look at a combined example. I threw in a picture. I won't go into details, but I grabbed a picture from IMDb, from a movie, and put it into the program. And as you can see, it is actually able to find some of the words you can actually see in the picture up there. Before I continue the presentation, I'll just show you something that the team, the computer vision team, did. So they created this guide, and they actually created a very cool tool that you can use. So you can, there's a lot of C# examples, and the good thing is that somewhere here, there are instructions on GitHub, or how to download this from GitHub and run the program, which I did. So I tried to throw in a couple of pictures. So this is a program you would get if you compile the GitHub project. So I don't know if you can read it up there, but it says that this is a cake that looks like a face, maybe. I don't know, but it tries to analyze it. And adult content, no, this is not dirty. The racy content, I had to figure out what that meant. Racy means almost dirty. It's kind of piquant, I think you would say in some languages. If you try to take something else, like a face, emmet, here, right? I don't know if you noticed, but it did made a call to Azure, and he's certainly not sexy, absolutely not. But you can see here, actually, since he's a known person, he can detect that this is Christopher Lloyd wearing a white shirt, and then apparently find something else. Just to show, and there's a lot of different settings and so on you can try out here, and you have the C# code, and which is not that difficult to translate into AL if you want to. So I'll go back to presentation for a couple of slides. This is actually the same program. This is one of my kids playing football, and I just tried to use different settings. So in the first one, I used describe settings, and you can see that it can figure out that this is a young boy playing football on a field. This is pretty good, right? And the other one, where I said recognize text, it's actually able to detect some of the things that are on his. Right, this is Alex Peterson and Stadium, right? Kind of cool, I think. Now, this is obviously fun, and I don't know, maybe this can be used for, I don't know. So, how do we weave this into our world with accountants and so on, salespeople? So in Business Central, we have our contacts card, and in the contacts card we have a small profile questionnaire at the bottom. I don't know if you're familiar with this feature, but we have. And these questionnaires, you can set them up, but there are some standard out of the box, and you can print. There's actually a report where you can print a questionnaire handout. So this thought of example I'm working on here is we take this example, print it in a number of copies, and then hand it out at a conference or a classroom or something, or some event. And then you might imagine that people will fill it in, and luckily 2 people did, in this case, some people we know in this team. So they ticked off, it's completely a coincidence that the handwriting is the same here. So, and they ticked off some crosses there, and names, and this is not nice writing, right? And you have this event, conference, but I mean, what are we going to do with all these things? Are we going to type them in manually? And no, we are not. So there's a recipe to do this, but before I do the recipe, I'll just show you in what you can do in here. And I'll go over here and remove Kristoffer. And hope this didn't time out. So I have 2 responses here. So I created this small app. It's basically a card with an attached picture, just like an item that I loaded in. And the other one from the other respondent. So go back to Gert. And I hope all connection is okay. I click process picture. Voila. So you can see that apparently it didn't quite get the N right? I mean, should be an N, and there's a space there, but otherwise it's kind of good, right? And the way it finds that the number of employees and what else it ticked off is that in the scanned result, we also get the X's. These appear as the text X. So we just need to find the question that has an X after, to the right of it. It's not perfect, because if I scan the other one, apparently the respondent was not as good with the crosses or the X's. Right, it didn't recognize those, but so it's not perfect. But I think it's due to the boxes around there. But anyways, overall this works, and you just remove those or make those boxes bigger or instruct people to do it. So how do we do this? Yeah, there's a short recipe. So one is to obtain a subscription. And by the way, there are free subscription, free samples, right? So you get the key and endpoint, and the endpoint is dependent on which region you are. You probably want this in a region near you. Then you post the request, and this is pretty similar to what Esben and those showed. So you, at the end, post the request, then you get a value, but since the processing can take some time, you actually don't get the picture. You just get a link to the result. So therefore, we need to wait for it. So down here, we wait for the result to appear, and then we read the JSON result. And by the way, the nice thing is all this are just regular AL types, no .NET or anything. And this is how a snippet of the JSON result looks. So I have a bigger picture of it. And I deleted some of the surrounding stuff just to get down to it. So you can see that once you get into it, it's pretty straightforward. So you see some text. So you have a text string, which is then broken into atoms. And one name that's broken into atoms. And then you have Gert Robyns and individual words. And you can see that it's not quite sure that it's Gert, but apparently very sure that it's Robyns. And the same with email, not sure that it's Microsoft. But this is how you can analyze, or you get the analysis of the text. And as you would know, the rounding boxes, or bounding boxes rather, they just point to where it is. And it actually has the full set of coordinates because it's intelligent enough to have a skewed, I mean, now this is pretty straight, but even if the text is angled, it will actually give you an angled box. And this is just what I just showed you. The other thing I want to briefly show, which is something that is very recent on the cognitive services, or Vision. So they have created something that they call a form recognizer, and this is in preview, and only in US obviously. But this is very close to what we would like for what they call key pair valuing. So if you scan in something like this, I mean you can't upload, but you can take their examples. You can see that it finds invoice for someone, address, invoice number, invoice date. So I think this is something we should take a look at. So there are some examples here. You can click here maybe, or here. This is not always responding. Anyways, sometimes it does, sometimes it doesn't. I think they have a very small server at the back end. So I think this is one of the coolest things that is going to come. I think that kind of concludes the... Yeah, this was this is another example I actually took. So even a receipt like that, it's actually able to pretty well figure out what it is. I think that concludes.
Sure. Thank you, Gert. So, great stuff. Lots of application, obviously, in ERP scenarios with these type of services. Now, Gert mentioned a few times telemetry, and when he showed you the IoT, and I'm going to talk a little bit about telemetry because when you are in the cloud, telemetry is really important. So, the robot here. If you imagine that you want to know what's going on, you obviously need to send a lot of data, a lot of information in order to figure out what's going on and monitor it and debug it. If you look at the definition of telemetry in Wikipedia, it says that it's the collection of measurements or other data at remote or inaccessible points and their automatic transmission to receiving equipment for monitoring. So that the robot on Mars is a good example of that. It's obviously very remote, but if you think about it, if you put your software in the cloud, if you run this in the cloud, this is also an inaccessible area. You can't get to it, so you need telemetry. But even if you are still have on-prem installations, if you want to debug it, if your customer is 100 kilometers from where you are, you probably have to jump in your car and drive out there and figure out what's going on if you don't have any telemetry. So that's why telemetry is important. Usually, telemetry conceptually is divided into several categories, and these categories are monitoring and alerting, diagnostic and troubleshooting, and usage. So monitoring and alerting is about finding out what's going on right now. It's about monitoring the system and being alerted if something goes wrong. Diagnostic and troubleshooting is finding out what happened. So looking back, what happened if you had a failure in the system, finding out what went wrong. And usage is more about what features are used, from a usage standpoint by your customer, by the users of the system, and how they're using it, how often, this kind of information. So it's not so much about troubleshooting and monitoring. It's more about, how the product is used. Another thing you can do with telemetry, which all the data I mentioned before for monitoring and troubleshooting, you could imagine you could do that in an on-prem world by logging messages into a file, and then you could go and look at that file and try to figure out what happens. But that might give you the kind of equivalent capability to do monitoring and diagnostic. But what you can do with telemetry, which you cannot do in the old-fashioned way, is to aggregate across tenants. So if you have a solution installed at many customers, at many sites, with telemetry, you can aggregate all these data into one place and do correlation between the different systems. So how to do that? I'm going to talk a little bit about Application Insights, which is an Azure service made for telemetry, and it has a lot of functionality. I'm only going to scratch the surface and show you a little bit of what it does. So how does it work? You have your extension. The idea is from your extension you emit events to Application Insights, and from there you can look at some metrics, create some alerts, get notified something goes wrong. You can do some analytics and even do some cool Power BI dashboard if you want to do that. So the type of emissions you can do to App Insights, there are basically five types, and the name of it in the blue box is actually the name of the function you call in the SDK. So the first one is called track page view. This is meant to be used to track which page are shown in your application. Track trace, just to log a diagnostic message, text message. Track event is a little bit like track trace, but you can also track, with track event, you would log a message, but also you can add some metrics to it, like some numbers, and App Insight will allow you to draw some graphs based on these metrics. So if you want to monitor some value, for example, in the cookie jar example, you could use that. Track exception obviously is to track error and error situations. And the two last events, I won't talk too much about it because they are more, for tracking certain metrics which are not performance related. For example, the size of a queue or something that runs in the background. And track dependency is for tracking. If you call an external system or an external service, you can use it in App Insights to differentiate from what's going on in your own application and what's going on in external services. So I'll focus on the four first ones, and on GitHub, again, we'll give you some pointers at the end of the presentation. We have a small SDK that implements these four type of emissions for AL. So let me do a quick demo of Application Insights. I hope my internet connection is with me. Let me refresh that screen. Okay, just give me a second. So this is Application Insight. This is how it looks like in the Azure portal. And you can look here at the events that have been emitted to this particular service. So if I go there and look at all the data, I haven't emitted any data in the last 24 hours, but if I look at the last 7 days, I should get hopefully some results. See, I have some different type of events here have been emitting to the service. So we have some page views, about 1,600 of them. Various exceptions. It's artificial data I generated, but you get the idea, right? So for example, if I want to see, I can filter on custom events here. And for example, I have telemetry here that at that particular time, I run a background job. I can look at it and get the information of that particular telemetry mission. So this background job was called synchronized with Office 365. So that's something, some information I send from my extension. You can also look at crashes. If you have any exception, you can figure out, try to figure out what happened. And you can also create alerts. So alerts are pretty cool because they will, you can create notifications. Let me figure out what they are. Here they are. So the way it works, it's pretty simple. You create a new alert rule. So you indicate here which resource you want to listen to. So in that instance, that's my application inside service. You can have more than one. And then you create a condition. So that could be something from, for example, like if I receive this error more than 10 times, or if this particular metric falls below a certain value, then the rule triggers. My connection is a little bit slow here, but you get the idea. So you define the signal type. Could be, for example, in Gert's example, it could be when the cookie jar gets below a certain value. And then when you've defined the rule, you select an action, and that action could be send me a text message or send me an email when that rule is triggered. So that allows you to have monitoring and alerting on your system. So how do you do that? Let me see. Let me get back to the right machine here. There we go. So let's look at how an emission to Application Insight works. Basically, you go and create the service in Azure, in the Azure portal, and you get a key. And to emit telemetry, you need to post a request to an HTTP post to that URL with a JSON object containing the information you want to emit. And this JSON has a pretty self-explanatory format. For track page views, look like this. Track trace, you have a similar format, but it has some message and some properties. Track event resemble track trace, except that you have another section here that contains some metrics. And finally, track exception, you have obviously an error message. So that's how the JSON you have to send looks like. So the recipe, very simple. Create an application inside service. In AL, create the JSON object with telemetry data. We have a JSON API in AL to do that. Invoke the application inside REST API, doing a post request. And then you can go from there and create dashboards and alerts in Application Insights and monitor extension. So the code looks like this. You have a bunch of variables, a client to do the post request, and some JSON objects. You create the JSON object. So in that example, this particular code emits a track page view event. So you create the JSON object that respects the format that Application Insights expects, and you just do a post request, and that's it. And it's very fast. It's very small payload. You don't really need the response. Basically, it's just respond OK when you send a post request like this. So you don't need to pass any result or anything. So it's very quick. So this is how you emit telemetry from your application, from your extension. I mentioned that in the keynote. We from version 15 of Business Central and above, we will allow you to bring your own application insight key into Business Central and configure it into the tenant admin center, and we'll send you a telemetry about long-running queries in the first version, so from 15x, and in the future we'll add some more telemetry about report execution time and about OData usage, and we'll keep adding to this. So that what it means is that if you create an application insight service, use it to emit your own telemetry from your extension, and you take that same key and bring it to the tenant admin center, we will emit into that same application insight service, which will allow you to correlate whatever happens. If you have a long-running query, you will be able to correlate it with your own telemetry and find out, is there some relation? If I have some performance degradation, for example, in the system, then you find out, what page have been viewed at the same time. So that you can imagine that opens up for a lot of, great scenarios for troubleshooting. All right, so that was about telemetry. Now we're going to get back to cognitive services. So Bardur talked about vision and talked about recognizing handwriting. I'm going to talk about another area of cognitive services, which is translation. So obviously translation is important if you need to translate your extension. And from a couple of releases ago, I believe, we introduced the xlif files, which is the way we recommend for translating extensions, and I'll show you how that works. So I have an extension here. It's very simple one, which just contains one single page, and it has a bunch of fields like custom name with some caption, balance. And I have some labels here just for the sake of the demonstration. And obviously, if you want to go international and publish your extensions in more than one country, you will need to translate your pages. So the first thing to do is to go to the app.json file in your extension and add the feature keyword with the translation file entry, just like that. And what happens here, when I'm going to build the extension and take a look at the workspace here, when I'm building, you'll see that it creates a new folder called translation, and in that folder I have a generated XML file that looks like this, which is a xlif file. So xlif is the international XML standard for translation. If you talk to a professional translator, they will know about this format. They use tools which understand this format. And it's a pretty simple format. It contains some translation unit like this. And there's a source tag here that contains the original string in the original language. And when you need to translate your extension, you just add a tag underneath called target, which contains the translated string in the language, in the target language, which we indicate here. And when you do that, so that's if you translate manually, we will, when you deploy your extension, all the magic in Business Central will happen. If you switch the language in Business Central, we will show the translated string that comes from that file. So all you need to do is to get into that, generate that file, which is done by the compiler here, and add all the targets for the translations. But translating manually is not fun. So we want to use the cognitive services and use the automatic translation. So to do that, we have another option, which is using the translated text, which is an Azure service. And it works like the other services. You create the service, and you get again a key, which is an API key, and that's all you need to start doing translation. The API is very simple. You post a request, again, same pattern here. You post a request to this URL, indicating the source language from which you translate to the target language to which you want to translate. And in the body of the request, you have a JSON package with all your strings, and what you get back is a JSON result with all the translated string in the language you want to translate to. So the recipe again, create a translator service, translator text service, generate the XLIF file by adding this entry, the features translation file in the app.json. Extract, you will need to pass the file and extract it from the XLIF file. Invoke the translated text API, send the JSON package with all of your strings, pass the result back, and put it back in the XLIF file. So that's the way to perform the automatic translation. So to do that, I have created a small extension, which is not a Business Central extension. It's a Visual Studio Code extension, not to be confused with the Business Central extension. So it's an extension written in TypeScript, and the code is available again on GitHub. But basically what it does, it implements the recipe I just showed you before on the slide. And I show it to you in action. So let's pick a language here. Let's say I want to translate to German. Then I invoke, so this command comes from, I've installed this Visual Studio extension here on my version of Visual Studio Code here. And this command actually invokes the Azure service, and you can see the magic happen here. I have the targets added to the file with the translation in German for this text. Let's pick another language. Let's pick, for example, French. And again, ask for translation. Now I get the translation in French, and you can also have like more exotic languages like Japanese, and you get translation in Japanese. It supports really a lot of languages. So when you use the translated text, as I did here in my example, when you just create the service, you will get a pretty generic machine translation, meaning the quality of the translation is as good as it gets when you do generic translation, meaning the neural network that is behind this doesn't know about ERP, so it's not as good as a human translation, most likely, especially in the ERP, because ERP has certain terms and a certain semantic that needs to be specific to the language, right? But what you can do is you can actually create a service. So instead of using the one out of the box, you can create a model and train it if you already have translation in your domain area, whether it's shipping or warehousing or whatever, and train with translation you already have, and you'll see that by doing that, you'll create so the recipe works the same way, but you'll have another service you can call with a trained model based on some high quality translation, and you will get a very high quality of translation out of it. It doesn't take a lot of training to improve the translation in a significant way. All right. So that was machine translation. So how much we showed you a whole bunch of services here in Azure, and you might be wondering how much does this all cost, because nothing is for free. Actually, a lot of it is for free. There are some price indications here. Application Insights, for example, costs, it's free for up to 5 gigabytes of data, and you saw, the payload of the JSON is pretty much the JSON packages you send are not very big. So for 5 gigabytes, you can emit really a lot of telemetry. Translation, you can translate up to 2 million characters per month, and that's quite a lot. That's also for free. The trained model I was talking about before are a little more expensive. But if you go over 2 million, it only costs like €8 per additional million of characters. OCR text recognition that Bardur showed you, also, 1 to 2 euro for 1,000 transactions. IoT Central is 5 devices for free, €1 per device, €2 per device per month. You have some prices for Logic App and keyboards. Service Bus, Service Bus, very, very cheap, 0.04 43 euro per million operations, right? And BLOB Storage and Service Bus Relay. So you can do a lot of these things for almost for free. And so these prices are only, an indication on how it costs, just to tell you, how low the prices of these services are. It's a little bit complicated to give the exact price. So if you're interested in calculating exactly how much it costs, you can go to this URL, which is the Azure price calculator. And you can enter the exact parameters of the services you want to use, in which regions and so on, and it will give you the exact price of these services. Finally, a couple of resources. Again, all the source code for what we've showed you today is available on GitHub at that address. So github/Microsoft/BCTech. We have an intention of keeping adding to that repo. I mean, feel free to download the code and contribute to it. Ask questions there if you have any doubt and any questions about how to use it. And we plan on all these small experiments and small prototypes and cool stuff we do on the side. We plan on adding them to this repo, and hopefully we will have it growing with more and more examples of that nature. We also have a blog post where we have posted articles which explain basically what we showed to you. So if you want to go back to some of these stuff and look it up in a blog post format, that's the place, aka.ms/bctech. That was what we had for today. Thank you very much. We have, I can see we have 8 minutes left, so if you guys have some questions, we'll be happy to take some questions now. Yep, just a second, I'll have a throwing box. That was you, right? Wow, good catch.
I wanted to ask you about the telemetry. Will
Yes.
it be available inside Business Central some logging of errors that happened? I mean, like missing setups or such things with tracing behind.
So yeah, so the plan. So right now we have, as I mentioned, right now the only thing we emit is about long-running queries, right? But we'll keep adding to this. And if you have some suggestion or something in particular you would like to see us emitting, go to ak.ms/bc-idea. That's the URL, right? And submit an ID here, and that's what we use to prioritize requests, right? And if people vote for it, we'll put it in, right? There's another question here.
Hi.
Hi.
We talked yesterday, but my question would be about the Business Central agent that you show that allows you to connect to the client, the end user, which is not available currently when using web client. So is this product produced by Microsoft and is shipped with the product, or is just a repository with the code where we can where we take the code and build the application and publish, and not sure about the maintenance of it?
So the agent, you mean?
Yeah.
The local agent. So it's on GitHub. It's not productized again. It's a prototype. You can just grab the code as it is and make it your own.
Yeah, but maybe in the future, can it be produced and shipped by Microsoft, and can we trust on this? Or
we don't have plan to ship it as a productized version of it, but go and look it up. It's very simple. There's not a lot of magic happening in there, so you can just as well take it, make it your own. I don't think you will need a lot of maintenance in that code, to be honest. I mean, it's few line of codes. We don't have plan on productizing it at that stage. Right.
Okay, thanks.
Yeah.
But I think that, another option is also to go to aka.ms/bc ideas, put it as an idea, and hope that enough of all of you
People vote for
upvote it.
Yeah.
It will be considered more actively.
Yeah.
Right now it's just a sample.
Other questions?
Yeah, we had an issue recently about files and other code pages coming in. The files which you get are not always Unicode, especially when they're from Azure. They're still using lots of legacy code pages. And my question is, can we expect any sort of integrated function to convert code pages to Unicode? in the future?
Well,
Because
okay.
Japanese, which you show Japanese here, but if you get files from a Japanese bank, they are likely to be in Shift JIS or something, which was they're still using that because UTF-8 is not very efficient coding for Asian because they take up to 3 bytes. So they're still using these code page formats, and if you get these files, you have to do something with them. And since we can't use .NET conversion anymore directly, will there be Azure functions available to do this?
So you can definitely write your own Azure function.
Yeah, no.
Conversion that
we can't expect anything in the standard coming along.
I think so. What you're talking about is when you have to import files, or
payment files coming in from Japanese banks or something.
Yeah. So we don't have this capability in the product today, right, guys? But Azure function is your friend.
That or actually add a pull request, as Jesper explained yesterday in at least the session I attended or were a part of, on the our other GitHub review, the system application. I mean, this sounds like a functionality that could fit in there.
That's something we'd have in the system app, and it's on GitHub, so you could write your own and do a pull request here. Right, thank you.
I have a question.
Yeah, okay.
Yeah.
Bardur has a question.
I have a question.
Okay.
So about telemetry, is it subject to GDPR?
Yes, thank you for reminding me.
Do we need to care about privacy? Can
Yes.
we harvest any information from the customer?
Yes, thank you for reminding me. We agreed I was going to mention that in the presentation. So obviously, when you emit information to telemetry, you need to respect GDPR and be compliant with GDPR, meaning it's a pretty complicated area, but in a sense, you shouldn't be emitting any information which can be tracked back to individuals, things like names, addresses, email addresses, and the list is long. But be careful with that. Make sure when you use telemetry, you're compliant with GDPR. Yeah, thank you for reminding me, Bardur.
We have a question over there.
There was a question over there.
Hey, thanks for brilliant demos. And my question is about demo when you send the files to storage account and to Azure Service Bus Relay. As I saw in variables, you had some management code units. Is a standard code units from base up, or you created some own behind the scenes?
Those are put on the GitHub repo. There's an Azure BLOB Storage library code unit, or actually extension, that wraps the functionality that was needed to do these samples.
Okay, I think it will be a good idea to include it in base up.
Yeah.
Thank you.
Yeah. Any other question? Over there.
A question to the BCAgent. Would it be possible to connect to local printers or something like that?
Yes.
Yes, absolutely.
And I mean, it's basically bridging towards a local running component. So if you can write it in a .NET language or connect to anything locally from there, you can do it.
Okay, thank you.
Yeah. Another question over there?
I have a question regarding document previewing. Is there any plans on integrating any components like from Office to better preview documents? Because we've seen attachments coming in and stuff like that, but we never really get an integrated preview.
So you mean for things like PDF documents? Or
like with Office, there's a lot of capabilities that you have with Microsoft, right? So I'm wondering why not better integrate.
Yeah, well, aka.ms/BCIDs. Yeah,
okay. But is there any plans?
Not that I know of.
Okay.
But if you get enough votes, that's definitely a relevant scenario for sure.
Okay.
yeah, we might. No.
Thank you.
Thank you. All right, thank you very much for attending this session. And go and have fun with Azure.